Hi guys, Miss Bella here, and
Mrs. Pesic here too.
Alright, in this video we're going to talk about dividing polynomials. So we're going to talk about synthetic division, the remainder and factor theorem, and also synthetic substitution. Alright, now, if you remember from our last video...
And the factor theorem too.
Oh, and the factor theorem. Whoops. Alright, from our last video, when we were asked to divide, for this example, x squared plus 5x minus 28 by x plus 4, we used long division.
Was this one of the notes must do or something like that?
Yes, it was. Alright, so we showed you the setup. We said we'd put x plus 4 outside because that is our divisor. Our dividend was x squared plus 5x minus 28, and we would do this long division process.
But that was a long process.
It was a long process. So, is there going to be an easier way? Yes, but only in certain cases.
Yeah, it only works. You can use synthetic division, but only if you're dividing by x plus a or x minus a. So if you were dividing something by, something like divide by x squared minus 5, then this synthetic division process would not work.
What if I was dividing by like 3x plus 7?
Still would not work.
Okay.
So if you're going to divide by 3x minus 7 or 3x plus 7, that's no good. So you cannot use synthetic on this or this. You would have to use long division for those processes.
Okay, so only x plus or minus a number. So let's see if this first example would work. In this first example, we have negative x squared plus 2x to the third plus 25 divided by x minus 3. So I notice it's in that form of x minus a or x minus 3. So we're going to set up our kind of notation for synthetic division. The first thing I'm kind of noticing is my dividend here is not in standard form.
Ooh, yeah, you got to fix that.
So if I fix this, let's say if I do 2x to the third minus x squared. Now there's not a term with x here, so I'm going to add in a 0 just to kind of keep things in order. Plus 25.
All right, so if there's a missing term, you have to fill in a 0 for that term.
Okay, all right, so what am I going to do next here?
We need to put a number outside here, kind of like maybe think about putting it like in a box kind of thing. And what number is going to be? It's going to be whatever number you would need to fill in for this x to make this parentheses equal to 0. So what would you need to plug in for x to get that parentheses to be equal to 0? You'd need to plug in a 3, so that's why 3 goes right there in the box.
And I always kind of remember that too. If I forget, I just make a little equation here and say, oh, add 3. That's how I know my value there. Perfect. Okay, so I'm going to first go ahead and I'm going to take my coefficients in front of each of these, and I'm going to bring them down. So I'll have a 2, a negative 1, a 0, and a 25. That's going to be my first step here. Whoopsie. There we go. Okay, so we have our values.
So there's the 2, there's the negative 1, because this is really a negative 1 right here, 0, and 25.
Okay, so what's my process here? First thing I'm going to do, I'm going to bring that first leading coefficient straight down. So I'll bring down my 2. Let's just scroll down just a little bit there for us. Okay. Next step, I'm going to multiply by whatever number I put outside in that box. So in this case, I'm going to multiply it by 3.
So the 3 here gets multiplied by the number below the line, if you want to make a line there. So we got 3 times 2, and that gives us 6. So we put the 6 right here.
All right, now my process, once I have that, is I'm going to add straight down. So that's how I'm getting negative 1 plus 6 is equal to 5.
All right, so we take the negative 1 plus 6, and we write that 5 right below the line, and then the process repeats again. So we're going to take the 5 here times the 3 here, multiply them together, and get
15. Okay, so again, you'll add down. So now I'm going to take 0 plus 15, all right, equals 15.
Okay,
and one more time.
Write that 15 below the line, and then repeat the process.
One last time. So 3, move this one out of the way, 3 times 15 is equal to 45. And then I'll add it one last time.
25 and 45 gives us the
70.
70.
Okay, now we need to know how to write our answer here, right?
Yes, because we can't just write 2, 5, 15, 70.
Okay, so how am I going to write my answer here?
Well, what I like to do is I like to kind of separate this last number, maybe with like a little wall here, because that last number is really the remainder of our division process, and these numbers here are really the coefficients of the quotient. Coefficients of the quotient. And how do we know what the variable should be? Well, this one is really the one right next to this little wall I drew in would be x to the 0. This one here would be x to the first. This one here would be x to the second.
So you just kind of count backwards?
I kind of just count backwards, starting with x to the 0, which is really just 1. So we would get 2x squared plus 5x plus 15.
Okay, now what do I do with that 70?
Well, that's our remainder, so let's write plus 70 over
Over
our
3?
divisor.
Should I put it just over 3?
Not over 3, it's got to be over our divisor, which was here. We're dividing by x minus 3. So this is how we would write our answer.
Okay. So, I think I see how those line up. Now, didn't we do the same problem with long division on the other notes?
We did.
All right, let's see how those two compare. So, if I scroll down here just a little bit, let's look at these similarities.
So this is what we did in the last video?
This was the last video, and this was the same exact starting problem.
Yeah, x squared plus negative x squared plus 2x cubed plus 25 divided by x minus 3. There it is again.
There it is. Notice this, we got the same answer when we did long division. We had 2x squared plus 5x plus 15 plus a remainder of, kind of scroll up a little bit there, 70 over x minus 3.
We got the same thing, long division and synthetic division.
Right, they both will give you the same one. Remember, synthetic is just a little shortcut, kind of, if you're dividing by x plus or minus a.
Perfect.
All right, we ready for another example?
Yes.
All right, let's try one more. 3x squared plus 9x minus 2 divided by the quantity of x minus 1/3.
Okay, so I would start off by saying, what do I need to put in the little box out here? Remember, that's going to be whatever you need to plug in for x to get this parentheses to equal 0. And that would have to be a positive 1/3.
Okay, I think I get that part. Now, I noticed in my dividend, it's 3x squared plus 9x minus 2. It's already in standard form, and I'm not missing any degrees.
Okay, so I can just fill in the coefficients. I don't need to write any x's, so I'm going to write 3, 9, and a negative 2.
Right, and I didn't need any zeros in this case.
Nope,
Perfect.
didn't have to fill in any zeros. I'm going to leave a little room. I'm going to draw a line.
Okay. All right, so I believe the first number, we'll just bring it straight down. So we'll bring down that 3.
So that comes straight down. 3 goes right there.
And now, what was our pattern? Multiply by the number on the outside there. So take 3 times.
So we're going to take this 3 here times the 1/3 here.
Yep.
And we're going to get 1.
1. Yep, that looks good.
All right. And then we add the 9 and the 1.
That sounds good. Add those down.
All right, so we get 10 there.
Okay, now we need to multiply that 10 by the 1/3 out front.
So who made up this problem? It's going to be Nancy Craig. So 10 times 1/3 is 10/3.
Yeah, or 3 and 1/3, whatever makes it easier for us.
Mr.
All right,
Dowger,
well,
please
let's
call
write.
extension 1100.
Oops.
Mr. Alex Dowger, 1100, please.
Technical difficulty. 3 and 1/3
Okay, so
added to negative 2.
it'd be positive 1 and 1/3.
All right. And so how are we going to write our answer?
All right, so let's put the little wall there to divide out the top, or the last number, so we know that's our remainder.
Okay.
All right, and we'll count backwards. So that 10 will have x to the 0 with it, and the
Okay.
3 will have x to the first.
Okay.
So our final answer should be 3x plus 10, because remember x to 0 is just 1, and now we need to write our remainder. So plus 1 and 1/3 divided by x minus 1/3.
All right. So that's our quotient
Just a
plus
reminder that the
remainder
physics study
over
table
divisor.
is in the cafeteria, in the back of
Okay.
the cafeteria. Again, physics study table.
Okay, so at this time, you got your first notes must do for this video. So just, you can pause this video if you would like. So you can do this. You're dividing using synthetic division.
Just a little reminder, make sure it's in standard form before you start. Fill in zeros for any degrees that might be missing.
And don't forget that you're going to put the number in the box. That's going to be what number do you need to plug in for x to get this to equal 0. So if you want to actually set it up and say x plus 2 equals 0, and then solve for x, that number that you get is going to go in the box right here.
All right. Okay, now when we use synthetic division, you can also evaluate polynomials, which means like figure out what value you would get by plugging in an x. So the process will be the same as synthetic division, but our final answer, will only really require knowing what the remainder is.
Okay.
So this leads us into the remainder theorem. If a polynomial function p of x is divided by the quantity x minus a, then the remainder r is p of a.
Okay, so how does that work? So if we're going to divide using synthetic division, with this example, 2x cubed plus 5x squared minus x plus 7, and we're dividing by x minus 2, then what?
So I'm going to set it up the same exact way. I'm going to make sure I'm in standard form, fill in my coefficients across the top. I'll change or figure out what x I need, and I'm going to do the same process. We'll kind of really figure out what this remainder is at the very end.
So we're going to do synthetic division?
We are. Same thing we did before.
Okay, so we're going to put a positive 2 in the box.
Looks good, yep.
All right, and the coefficients, are we all in order here?
Yes, we are.
Nothing's missing?
Nope.
So I don't need any zeros. So 2, 5,
-1, 7.
-1 right there, and a 7.
All right, so process one more time here just to practice.
All right, we bring down the 2 from right here.
Okay, then we want to multiply. We're going to multiply this 2 by this 2 right here.
All right, and we get 4.
Okay, and then you add down the row.
So that's going to be 9.
And then I'm going to take this 9 now times this 2 out here.
All right, and that's going to give us 18.
Good. Add down.
So that's 17.
Okay, we'll take this 17 times this 2 out here.
And that's 34.
And then add one more time.
And we get 41.
1. Okay, now, we don't, leave the 17 there. We're all done multiplying. Maybe we want to wall off that last number again.
Okay.
So what this theorem was really telling us is that that last answer you get, that last number, your remainder,
This number right here?
that 41, yep. What that is, if we just look at that theorem real quick there, that the remainder is really the same thing you would have gotten by plugging 2 into the original equation.
Huh. So if we just plug 2 in, like just evaluate this, like the original polynomial by plugging in 2, we would get 41?
You would get 41.
Can we test that?
Sure we can.
All right. So if we take this like as a function, like f of x equaling 2x cubed plus 5x squared minus x plus 7, and evaluate for f of
2.
2. So if we do that directly,
Sure, yeah, direct. Just plug it right in and evaluate what it is.
you're saying this is going to turn out to be 41.
I bet you it will be.
All right, let's see. So we get 2 cubed is 8, times 2 is 16, 2 squared is 4, times 5 is 20, minus 2 plus 7, I'm getting 36, minus 2 plus 7, 34 plus 7 is 41.
There it is.
It does work.
Pretty cool.
That is pretty cool. So you're saying that last number is going to be, that last number is our remainder, and it's also what you would get if you were evaluating the function.
Yep.
Awesome.
Always works. All right, do we want to try one more real quick just to see what it would be?
Sure.
Okay, so we're going to find f of 4. Now notice in this one I told you what x value to use. It didn't say like divided by x minus 4 or divided by x plus 4. So your number outside in that box should be 4. You shouldn't change it over.
Okay. So we're supposed to be doing direct substitution and synthetic?
Yeah, just to test that. Maybe we can do the synthetic first, and then we can
Okay.
prove that it works with direct.
Okay, so if we're going to do synthetic, we're going to put the 4 in the box?
Yeah, because it didn't come with an x this time. It was just what is x equal to.
Okay, so we're going to put 4 in the box, and we need our coefficients of 2.
Now, I don't see an x squared.
So should I just put -3 and 6?
No, you need to put a placeholder there, so you want to make sure you put a 0
Okay.
in for where the x squared term would be.
All right, so we want 2, 0, -3, and 6.
Okay, and we'll bring down the first term,
All right, so bringing that straight down goes a 2.
and now we want to go ahead and multiply,
So 4 times 2 is 8.
add down,
So we get 8,
multiply,
32.
add,
That's 29.
multiply,
That's going to be
116,
80 plus 36. 116. And that's 122.
Okay, so using that last theorem, this is telling us that f of 4, so when you plugged in 4,
So let me see. So you're saying f of 4 then is going to equal 116.
nope, 122.
Oh, I'm sorry. I was looking at the wrong number. Equals 122.
And so that should be the same as doing direct substitution.
All right, should we try that real fast?
Sure.
So we're going to try f of 4 using direct substitution.
And that just means plug it right into the equation.
All right, so it's 2 times 4 cubed minus 3 times 4 plus 6.
Okay, so 4 cubed is 64,
So 2 times 64 is,
128,
and then minus 12 plus 6. 128 minus 12 is,
116,
plus 6 is,
122.
hey, we got the same answer with direct substitution and synthetic substitution.
That's pretty cool. I think I would prefer synthetic.
Oh, I would too.
Little quicker there. All right, so your second must do. So must do number 2, you have synthetic substitution, evaluated for x equals -1. So notice you're not going to figure out what x to use in the box. You're just going to use that -1.
So you're going to put -1 in the box,
Mhm.
do synthetic division, except we don't really care about the whole answer. We only are looking for that last
Right.
answer.
You only really care about what your remainder is that you get down here.
All right, the number after you draw in your little wall.
Your little wall. Okay.
All right, sounds good.
All right, so pause it and then come back when you're done.
Okay, so recall that if a number is divided by any of its factors, the remainder is going to be 0. So likewise, if a polynomial is divided by any of its factors, the remainder will be 0 also. That brings up the factor theorem.
So if for any polynomial function p of x, x minus a is a factor of p of x, if and only if p of a equals 0.
Well, does that mean if we do synthetic division and we get 0 as the remainder, that very last number after the wall, then the number, the divisor is a factor?
Correct.
All right.
So it means you should have nothing kind of left over.
All right, so we're going to test one?
We're going to test one. All right, so we're going to determine whether x minus 2 is a factor of x to the third plus 5x squared minus 7x plus 2.
We don't have to try and factor this thing, do we?
No, we do not.
So what are we going to do?
We're going to use synthetic division, and we're going to see what our remainder would be. If the remainder is 0, it goes in evenly, so it's a factor.
All right, so if we're doing synthetic division and we're dividing by this, then we're going to put positive 2 in the box?
Right, because remember, it's kind of like setting it equal to 0 and solving it for x.
All right, and so then we need our coefficients right next to it, so that'd be a 1, 5, -7, and 2.
And those are in decreasing order. We're not missing anything, so that's good.
Okay,
All right, so let's do our process one more time here. So we're getting the hang of synthetic. Oh, scroll. All right. And, all right, so you're going to bring the first number down,
okay,
and we will multiply that by the number out front by the 2.
so the 2 times 1 is 2,
Add those down,
we get 7,
multiply.
2 times 7 is 14,
Okay, add those,
7,
multiply,
14 again,
and add.
16.
So we'll wall off that last number. So I got a 16, which means my remainder is 16.
So that's no good, because if our remainder is 16, then it didn't go in evenly.
Right, so it is not a factor.
All right, so we'll say x minus 2 is not a factor. But if we had gotten a 0 here,
Then it would have been,
then it would have been a factor.
which meant it would have gone in evenly.
Okay,
So kind of like when we did the product sum, like that would have been one of the parentheses. You would have had one of the factors at the end. Now this is x to the third, so we would have had more than 2 sets of parentheses, but
okay.
kind of the same idea.
All right, do we have another example?
I think we might have one more must do for your notes.
All right.
All right, so our last must do is you need to figure out whether x plus 2 is a factor of 4x squared minus 2x plus 5.
Okay, so we're going to do synthetic division.
Make sure you figure out what x value you need to use for the outside.
And then if you get a 0 as a remainder, then you'll say, yes, x plus 2 is a factor.
And if you get a number besides 0, you'll say, no, it is not a factor.
Okay.
All right, and that ends our video. Thanks for watching.
All right, make sure you write down your 3 questions on an index card or some small piece of paper index card size. And we'll see you next time.